Next up about waves is superposition and Young's double slit interference for C.3. Let's talk about superposition. It occurs when two wave pulses meet to form one resultant wave, and the resultant amplitude is equal to the sum of the two amplitudes of the separate waves. After this, the wave pulses continue along their direction untouched. It's that one superposed wave is not going to continue to be that way. The two waves move along on their own paths. There can either occur constructive interference, which is when two waves meet in phase, so crest meets crest, trough meets trough, such that the resultant amplitude is greater than the individual amplitudes. And then you have destructive interference, which is when two waves meet in antiphase, or when crest meets trough and trough meets crest, such that the resultant amplitude is lower than the individual amplitudes. And path difference is just a measure of the difference in distance traveled between the two waves from a source to a given point, typically expressed as a coefficient of the n of the wavelength lambda. For constructive interference, the path difference is generally equal to n lambda, where n is the integer, just an integer, and path difference for constructive interference is n plus 1/2 multiplied by lambda. And here you can see the difference here is in the 1/2 lambda is what causes the destructive interference. Then you have Young's double slit experiment. It's just an experiment where a monochromatic coherent light source, which just means you can learn that. We'll talk about what that is later. But it's just light waves emitted towards a screen with two slits. The light diffracts, as we mentioned diffraction earlier, and it creates an interference pattern seen on the optical screen behind the slit screen. And the screen will have a pattern of dark and bright fringes due to the occurrence of both constructive and destructive interference. Here, as you can see, these are wavefront diagrams, and as you know, wavefronts are separated. Each wavefront is separated by wavelength, and each wavefront represented here is of the same phase. And because they're all in the same phase, when these wavefronts intersect, these are points of constructive interference. Constructive interference occurs here, for example, as you can see. And accordingly, whereas there's construction interference, you have bright fringes, which is where you can see the light, and you have dark fringes where you don't see the light in between each bright fringe. So you have a bright fringe, and then a dark fringe, and then a bright fringe, so on and so forth. And then you have a formula for this. S is equal to the distance between adjacent bright fringes. And the formula is S equals lambda big D over little d, where big D is the distance between the slit screen and the optical screen here, capital D, and little d is the distance between the slits over here. And that's all you need to know for Young's double slit experiment. That's all the SL content for C.3. There's still more HL content for it, which is quite significantly more difficult, but we will rest assured get it done.